Next, let's talk about vibration. So to test this, you want to drive your coach at a variety of speeds on and off the gas, and basically you want to replicate what exact conditions that vibration occurs under and determine what part of the coach it's coming from. So you want to feel, is it steady? Does it kind of pulsate, kind of come and go? Does it come from the steering wheel? Does it only happen at certain speeds or get worse at certain speeds? So if it's a driveline issue, typically the vibration is going to change feel whether you're on or off the accelerator. So that's something you can check for. If it does seem to change with driveline issue, then you can check your driveline balance, check its angle, check what shape the U-joints are in. If it's a brake issue, then it's going to occur or at least change when you hit the brakes. So this can indicate warped rotors or drums. Your tires or your wheels may be either out of balance or out of round. So if you feel the vibration in the steering wheel, the issue is likely with a front wheel and or tire. If you feel it in the floor or the seat but not the steering wheel or dash, typically this is going to indicate a rear wheel or tire issue. And then, does it seem like vibration just gets worse the faster you drive? If so, typically that indicates a roundness issue. If it comes in at a certain speed and diminishes above or below that speed, then that can indicate a balance issue. So for a potential roundness issue of tire and or wheel, you want to check your tires for runout, which is the variation between the smallest and the largest diameter of that tire. So basically you want to jack it up and spin it and just see how much that outer edge tends to move in and out. And then do the same with your wheels as well. It is important to note that roundness may not be checked if the tires are just spin balanced. So that is something that you may need to pay a bit more attention to. Ask the shop to actually check for you, as they may or may not be paying attention to that. Another thing to note is that with hub-centric wheels, so that is the wheel is designed to center on the hub itself rather than stud-centric, which is where it would center on the studs. With that setup, the wheel tire assembly can still sometimes be mounted off center, and that's just because you can have a little bit of slop in how that wheel fits around the hub. So in that case, you can use a centering tool or tapered lug nuts to center the wheel on the studs before tightening down the factory lug nuts, just to get that wheel perfectly centered. So here's an example where it's just a taper. These fit into the holes in the wheel for the lug studs, and you just gently thread them down by hand to get the wheel centered. Put them in 3 locations around the wheel. Once you have those centered, then you put your factory lug nuts on in the other locations, get the wheel locked into place, then go back, remove these, and then install all of your factory lug nuts. So it is important to note that with this type of setup, typically these are just used as an installation tool. It's not actually to be used to hold the wheel on, because most factory lug nuts do have kind of a captive washer, and they're designed to clamp down on that wheel in a certain way. Another issue we find is loose dash structure or broken body welds. So sometimes a vibration issue can be caused or at least magnified by a broken bracket, like a loose or broken piece of structure either in the dash or on the body mounts. Here's an example where this piece of square tubing, this is actually a body mount, so that's the way that this chassis manufacturer mounted the body structure to the frame of the chassis, and the weld used was just not adequate, and as a result the weld broke, and this whole piece has been working up and down, scraping along the frame. So as you're going down the road, the whole body is able to just rattle and flex and shake. So it's taking those inputs from the road and now potentially just magnifying them as this whole body structure is now shaking. It's also possible that it could be an engine issue. So if you have an intermittent misfire, that can sometimes cause a vibration issue. Typically, this is going to change with engine speed, so the faster your engine is revving, the more you're going to feel that vibration, or at least at a higher frequency. But it is possible that the misfire could be specific to a certain engine load and or speed, and just kind of come in and go at a certain point. So sometimes that can happen. Sometimes it can be minimal enough to not throw a code even. So that's where finding a vibration issue can be tricky, but just have to be systematic and go through all the different pieces of the system and at least start identifying, which things can be eliminated.